There was a time when every ocean on Earth was sealed under a kilometer of ice, and it lasted 25 million years. Life should not have made it through. But something held on in the dark. And that fact is the reason complex life ever appeared on this planet. Tonight, you will understand how the world froze, what kept life alive, and why this catastrophe is the reason you exist. Imagine the entire surface of this planet, every ocean, every shoreline, every place you have ever stood, covered in ice, not for a season, not for a century, for 25 million years. This was Earth hundreds of millions of years ago, before forests, before animals, before bones, before eyes watched the sky. The planet was not dead, but from space it may have looked almost impossible for life. The oceans were sealed beneath ice. Sunlight reflected back into space. The surface became silent, white and cold enough to trap the world in a freeze that should have ended the story of life before complexity ever began. And somewhere beneath all of that ice, something was still alive. The mystery is not only how Earth froze. The deeper mystery is how life survived long enough to become everything that came after. Tonight we are going back to a world before forests, before animals, before bones, before eyes watched the sky. Earth looked almost perfect. And then, in geological terms, overnight, it was gone. Before we descend into what happened, you need a way to hold the scale of it. The Earth is 4.5 billion years old. That number sits without weight. So compress it. Make it a single day. 24 hours, midnight to midnight, the entire history of this planet pressed into one clock. At midnight, the planet forms, still molten, still deciding what it will become. Minutes later, a body the size of Mars crashes into it. The debris from that collision becomes the moon. By 4 in the morning, the first primitive life appears. Single-celled. Simple. Barely distinguishable from chemistry, but alive. For the next 16 hours, bacteria rule this world. They colonize the oceans, learn to pull energy from sunlight, and build hard limestone structures on the seafloor. Small, ancient, patient, and slowly, grain by grain, making the planet more hospitable for whatever comes next. By 8 in the evening, something extraordinary is close. Life is on the verge of its next great leap. More complex cells, larger structures, the first faint architecture of what will eventually become an animal. At 8 hours and 27 minutes past noon, the thermostat breaks. Now hold the paradox for a moment. The disaster that should have ended life may be the precise reason that anything as complex as you exists at all. The freeze did not simply interrupt the story of life. It threatened to close the book before animals, before forests, before eyes, before breath, before anything could look back and wonder how close the world came to silence. Without it, Earth might have stayed what it was for far longer. A warm, shallow ocean full of invisible microscopic life. Safe, stable, ancient, and small. No bones. No movement across land. No sleeping creatures beneath trees that had not yet evolved. The catastrophe was not an interruption. It was the cause. And the evidence is still there. In the Australian outback, in Death Valley, in remote mountain ranges and old seabeds, the story is still written in stone, waiting for someone who knows how to read it. It all begins with a single boulder sitting in the wrong place entirely. A glacier carries rock. As it moves across a landscape, it picks up whatever sits in its path, boulders, pebbles, dust, and carries them for miles before the ice melts and drops them. Wherever they land, they stay. Scientists call these transported boulders drop stones. And the problem The thing that stopped geologists cold is that they found them in places no glacier should ever have reached. In the Australian outback, a geologist stood in a dried creek bed and looked at a rock sitting in fine sediment. Mud, silt, sand. The kind of material that settles slowly in still water and has no physical mechanism for moving objects of significant weight. But the rock was a boulder, a foreign piece of stone dropped into ancient ocean floor sediment by the only force on Earth capable of carrying something that size across thousands of miles. Ice. The same story was playing out in Death Valley, one of the hottest, most inhospitable places on the modern Earth. Ancient glacial dropstones sitting in the sediment of what had once been a seafloor, 650 million years ago. Two of the planet's most extreme deserts, thousands of miles apart on different continents, both buried under ice at the same moment in deep time. The obvious explanation was geography. The continents were not always where they are now. Australia could have been positioned near the South Pole during the freeze. That would have been the comfortable answer. But rocks record where they formed. When certain minerals cool from molten stone, they align their magnetic particles with Earth's magnetic field at that exact moment. That alignment tells you the latitude, how close to the equator the rock was when it solidified. It is a compass baked into the geology itself, and it does not adjust or drift or lie. When scientists measured the magnetic signature of the rocks beneath the Australian dropstones, the result was not ambiguous. Australia was at the equator during the freeze, not near the poles, not in a cold band of latitude. Directly beneath the tropical sun, at the warmest point on the planet's surface, when the ice arrived and deposited those boulders. The result was so counterintuitive that some scientists proposed the entire Earth had literally tipped sideways on its axis, that the poles had shifted to where the equator normally sits, because a planetary tipping seemed more physically believable than equatorial ice. The idea that Earth had fallen over was easier to accept than the truth. But the evidence came from too many places, too many independent sources pointing to the same answer. If you have ice at the equator, the warmest place on this planet, then the ice did not stop at the equator. If the tropics froze, everything froze, every ocean, every shoreline. Every drop of surface water on Earth sealed beneath a sheet of ice that in places reached more than a kilometer thick. Not a regional ice age, not a cold spell in the northern latitudes. The entire planet from pole to pole wrapped in ice, a snowball. Knowing what happened was only the first mystery. The harder question came next. What could break a planet's climate so completely? The answer is a gas with no color and no smell that every creature on this planet exhales with every breath. The Earth has a thermostat, not a dial or a switch. A chemical process, billions of years old, that has kept this planet warm enough for liquid water and cool enough for life for longer than any other world we have found. Scientists call it the carbon cycle. And 650 million years ago, three things happened at almost the same time that broke it. Carbon dioxide is the atmosphere's heat blanket. More of it means a warmer planet. Too little means a frozen one. The balance is maintained by two forces working in opposition. Volcanoes releasing CO2 into the air, and the weathering of rock absorbing it back out. Rain falls on rock, the rock dissolves slowly. The CO2 it absorbs gets locked into limestone on the sea floor. Volcanoes replenish what weathering removes. Over and over, for billions of years, the balance holds. Then, around 716 million years ago, the first of three problems arrived. A supercontinent called Rodinia, which had held much of Earth's landmass in one connected piece, began to break apart. Its fragments sat at the equator, where conditions were hot and wet. Heat and moisture accelerate weathering. As Rodinia fractured, fresh volcanic rock dissolved faster than almost any rock before it, pulling CO2 from the atmosphere at an accelerated rate. The heat blanket was getting thinner. The second problem: the sun. During this period, the sun was approximately 7% dimmer than it is today. That sounds small, but a 7% reduction in solar output, combined with a thinning CO2 layer, is the difference between a livable planet and a frozen one. The third problem arrived with a name: the Franklin Large Igneous Province, remnants of which still cover parts of the Canadian Arctic, was a series of eruptions unlike ordinary volcanoes. They produced fire fountains, jets of molten rock spraying upward with such force that they may have launched sulfur dioxide high into the atmosphere. At those heights, sulfur can linger long enough to reflect sunlight and cool the surface. A third weight applied to a thermostat already under pressure. But none of those three forces were the worst part. For 3 billion years, cyanobacteria had been the backbone of life on Earth. These ancient organisms had colonized the oceans long before anything else existed. They were the reason any other life could function, and they were making things worse. Cyanobacteria absorb CO2. They pull it from ocean water and lock it into hard limestone structures. Dense reefs of ancient carbon, some of which still exist today in southern Australia. Pour a weak acid onto one of those fossils now, and something happens that is almost impossible to process. Ancient CO2, locked into rock for hundreds of millions of years, fizzes out as visible bubbles. The gas that once helped keep this planet warm. Still there, still traceable, released by a drop of acid on a piece of the deep past. The organisms that had sustained life for 3 billion years were, in combination with weathering in a dimmer sun and a catastrophic eruption, pulling the heat blanket off the planet. Not by design. Not through any failure. Just chemistry. Doing what chemistry does, until there was not enough CO2 remaining to hold the temperature above freezing. And that is how the thermostat failed. Not from one disaster, but from a slow alignment of forces that all pushed the planet in the same direction. Rock pulled warmth from the sky. A younger sun gave less heat. Sulfur dimmed the light. Life itself helped lock carbon away in stone. Each force alone might have been survivable, but together they turned a stable ocean world into a planet balanced on the edge of ice. The temperature dropped. The first ice formed. And now the disaster had its opening. All it needed was one final mechanism, one physical loop powerful enough to take a cooling planet and turn it into a frozen one. Sea ice reflects 85% of the sunlight that hits it. Open ocean reflects less than 10%. That difference, 85 against 10, is not just a measurement. It is the mechanism that turned a cold period into a global catastrophe. The moment ice begins replacing ocean, the planet absorbs less heat. Less heat means the temperature drops. A dropping temperature means more ice forms. More ice replaces more ocean. And on it goes, a machine that, once moving, runs without any further cause, until there's nothing left to freeze. Understanding how scientists discovered this threshold requires leaving ancient geology entirely. In the 1960s, Soviet climate scientist Mikhail Budiko was running energy balance models to explore what would happen to Earth's climate if nuclear war darkened the sky. He was not thinking about ancient rock. He was not thinking about 650 million years ago. But his model revealed something ancient, a specific threshold, a latitude roughly 30 degrees north and south, the latitude of modern New Orleans, beyond which, if ice ever expanded that far, the growing reflectivity of expanding ice sheets would prevent enough solar heat from reaching the planet to stop the loop. Once the ice crossed that line, no natural force remaining on the surface could reverse it. Nobody connected Bodico's threshold to ancient geology for decades. But 650 million years ago, the ice crossed that line. Not suddenly. The glaciers advanced the way they always advance, millimeters per day, inches per year, so slow that a generation of bacteria could live and die in the shadow of advancing ice without witnessing any visible change. But they moved. And when they reached 30 degrees latitude, the feedback locked in. The ocean, which had absorbed sunlight and held warmth for the entire history of life on this planet, began to disappear beneath ice. Sunlight that landed on the new ice reflected straight back into space, warming nothing. The temperature dropped further. More ocean froze. More sunlight was reflected away. In the 24-hour clock of Earth's history, the entire locking of the planet happened between 8 hours, 27 minutes and 8 hours, 35 minutes past noon. 8 minutes on that clock represents 25 million years of unbroken ice. By 8:35, every ocean was sealed. Every shoreline buried under a kilometer of frozen water. The world that had been warm and alive since 4 a.m, that had learned photosynthesis, built limestone reefs, been preparing for something more complex, was now a white sphere drifting through space, reflecting most of the light it received and growing colder still. For life, this was a test unlike anything before. If you imagine Earth from space during this time, it would not look blue. It would shine. A pale ball reflecting sunlight away, beautiful in a distant way, lethal to almost everything we think of as alive. No forests, no animals, no open ocean under a bright sky. Just ice, storms, volcanic peaks rising above the white, and the hidden chemistry beneath. Somewhere inside that frozen world, life had to find a way to hold on. A glacier does not look like a place where anything should live. No warmth, no soil, no visible food source. Light that arrives, if it arrives at all, comes as a pale suggestion rather than real illumination. The walls are ice. The temperature stays below freezing. By every easy measure of comfort, a glacier is the wrong answer. And yet life has been found there. Scientist Hazel Barton descended into an ice cave beneath an Alaskan glacier and found communities of living organisms thriving inside the cold and dark. Not near the entrance where some warmth reached. Not only at the edge where outside air might drift in. Deeper, in the ice itself, feeding on rock, active and alive. Some of those organisms were cyanobacteria, the same ancient kind of life that had existed on Earth for billions of years before Snowball Earth. Their survival is not metaphor. It is biological engineering refined across deep time. A human cell, when it freezes, can be torn apart by ice crystals forming inside it. Membranes rupture. The chemistry of life breaks. But some microbes have ways of resisting that damage. Their cell walls, protective chemistry, and ability to slow down almost everything allow them to survive cold, dryness, darkness, and long waiting. You can take certain cyanobacteria, dry them for long stretches of time, add water, and watch them return to activity with astonishing speed. That matters because Snowball Earth was not simply cold. It was sealed. The surface ocean was trapped beneath the ice. Light barely entered. Food was scarce. The world above had become a lid. During Snowball Earth, Life had to survive in margins, so narrow they almost disappear when you try to imagine them. Thin places in the ice where a little light may have passed through. Pockets of briny water kept liquid by salt. Cracks where rock and ice met. Hydrothermal vents in the deep ocean, where Earth's heat continued beneath the sealed sea. None of these places were comfortable. They were not safe in the way surface life understands safety. They were cold, dark, chemically strange, and isolated. A living cell inside that world could not ask for warmth. It could not wait for spring. It could not move toward an open ocean under sunlight, because that ocean no longer existed at the surface. It had to endure where it was. And that is the quiet terror of Snowball Earth. Life survived, but only barely in hidden spaces the planet had almost closed. Life did not merely survive the freeze. It adapted to the interior of it. It did not need comfort. It needed cracks in the impossible. Those cracks existed, and life found them. In faint light, in brine, in stone, in chemical energy leaking from the Earth itself. The planet was sealed, but not perfectly sealed, and life found every margin. But survival was not enough. Life could endure inside the ice, but it could not thaw the planet by itself. There is only one force powerful enough to break through a kilometer of frozen ocean. For 25 million years, it had been building. For 25 million years, the surface of Earth was silent. No waves, no open tides, no wind-driven movement across water, because there was no open water, only ice, white and still from pole to pole. The sun rose and fell across a planet it could barely warm, its light bouncing straight back into space. But the planet's interior did not stop. It never stops. Deep beneath the frozen crust, volcanoes kept erupting as they always had. Their lava could not always break through the ice above them, but the gas they released had nowhere to go. Under normal conditions, CO2 released by volcanoes gets absorbed. The weathering of rock pulls it back out of the atmosphere and maintains the balance. But during Snowball Earth, the rocks were buried under ice. No rain fell on exposed stone. The weathering process that had maintained Earth's climate for billions of years had nearly stopped. So CO2 had only one direction available: up, into a frozen atmosphere with no strong mechanism left to remove it. For millions of years, it accumulated. Slowly, steadily. The concentration of CO2 in that locked atmosphere climbed to levels far higher than anything in the modern world. The heat blanket that had been stripped away before the freeze was returning, layer by invisible layer above the ice. Then, somewhere near the equator, the ice grew thin. A dark patch of water opened, just a thread of it, barely visible against the white. But dark water absorbs heat. The water warmed. The ice around it melted. More dark water opened. More heat entered. The machine that had sealed the planet in ice began dismantling itself. But the thaw was not gentle. The CO2 that had spent millions of years building in the atmosphere did not release its heat gradually. The greenhouse effect it produced was extreme. Temperatures may have climbed rapidly in what was, by geological standards, almost no time at all. The longest winter in the history of this planet ended not in a slow spring, but in a violent planetary fever. And in the chemistry of that collapse, something happened that would change everything living on this world forever. As the ice melted, the planet moved toward oxygen levels it had never sustained before. The exact pathway is still debated, but the result was unmistakable. Oceans changed, newly exposed rock washed nutrients into the sea, chemistry shifted, and oxygen became available in ways that complex life could finally use. Before Snowball Earth, Oxygen had been far too low to support animal life as we know it. After the thaw, Earth began moving toward a more oxygen-rich world, not just a little more breathable, but biologically different. Oxygen is fuel for complexity. It lets cells release far more energy from food than older pathways could provide. More energy means larger bodies become possible. More energy means cells can specialize. More energy means life can begin doing things that simple survival never allowed. The freeze nearly ended the biosphere. The thaw gave it power. And life, the same life that had survived the dark and the cold and the long wait, entered a planet changing in its favor. What happened next was the greatest transformation in the history of this planet. The disaster that should have ended everything created everything. Before Snowball Earth, life on this planet was almost entirely invisible. You could have held a sample of the living world in your hand and seen nothing with your eyes. Microscopic, single-celled, ancient, simple. Life had been that way for 3 billion years, and without pressure, evolution does not hurry. Before the freeze, this might have been a slime world for ages longer. If Earth's thermostat had not broken, if Rodinia had not fragmented at the equator, if the sun had not been dimmer, if volcanic sulfur had not cooled the sky, if cyanobacteria had not helped pull CO2 into stone, the warm, stable, perfectly comfortable ocean, full of microscopic life, might have continued on its quiet path. There may have been no urgency pointing toward complexity. The catastrophe became the mechanism. After the great freezes ended, the world was no longer the same. Oceans had changed. Nutrients were moving through the water. Oxygen was becoming more available. The old stability had been broken, and life entered a planet with new possibilities. But possibility is not the same as certainty. Surviving the freeze did not guarantee that life would become complex. A microbe can endure almost anything and still remain a microbe. A cell can live, divide, and wait for millions of years without ever becoming a body. Survival alone does not create eyes, movement, tissues, or shape. For life to cross the next threshold, cells had to do something far more difficult than simply stay alive. They had to cooperate. They had to specialize. Some cells had to take on one job, while others took on another. Some had to form surfaces. Others had to form interiors. Bodies had to hold together, feed, grow, repair themselves, and leave some kind of pattern behind. The frozen planet had ended, but the next world had not yet begun. There was still a question hanging over the ancient sea. Would life remain invisible, or would it finally become something large enough for the Earth to remember in stone? Not long after the great freezes ended, the rocks of South Australia began preserving something extraordinary. The first large, complex organisms visible to the naked eye. Soft-bodied forms, pressed into ancient sea floors, with shapes that hinted at a new biological world. Some had repeated segments. Some looked like fronds. Some carried body plans, so strange that scientists still debate how they fit into the tree of life. Not our direct ancestors, perhaps, but a sign that life had crossed a threshold. Cells were now working together in bodies large enough to leave their mark in stone. Interior and exterior. Direction, pattern, structure. The first great experiment in visible life had begun. For the first time in the history of this planet, life could be seen with the naked eye. That sentence is quiet but enormous. For more than 3 billion years, the living world had been invisible. Then, after the greatest freeze in Earth's history, life crossed a threshold. Cells worked together. Bodies formed. Oxygen supported new metabolisms. Complex organisms spread across ancient seas. In geological time, this was not a slow drift from nothing. It was a door opening. We were not there. No ancestor of ours stood on the ice. No eyes watched the white planet from a shoreline, because shorelines were buried and eyes had not yet evolved. But every cell in your body belongs to a chain that passes through that time. Somewhere in that frozen world, something alive did not die. Because cyanobacteria clung to rock in ice caves. Because microbes fed on mineral energy in total darkness beneath a kilometer of frozen ocean. Because life found every crack and thin margin and hidden pocket of warmth and held on without knowing that holding on was enough. The catastrophe did not spare life. It forged what came next. Picture the ice now, not as a threat, not as a wall or a weight. Picture it as a lid over an ancient world, holding a secret beneath it. Under that ice, in darkness, in the absolute cold, in the silence of 25 million years without a wave or a tide or a season, something waited. Not with intention, not with hope, just with the quiet chemistry of survival. The same chemistry that had been keeping life going since the very beginning, patient enough to outlast a frozen planet. And then, at some point that no creature on Earth witnessed, the ice at the equator grew thin. A crack, a thin thread of dark water opening to a sky that had not looked down on an open ocean for longer than the dinosaurs would later exist. The warmth spread, slowly, then faster. The ice that had sealed the world collapsed into the warming sea. The longest winter in the history of this planet was over. What came after? Every animal, every forest, every ocean current and coral reef and migratory path is the world you are lying in right now. The oxygen in this room belongs to a long story of freezing, thawing, weathering, photosynthesis, and survival. The cells in your body carry chemistry refined under pressure those organisms should not have survived. The complexity that makes you capable of thought, of sleep, of being here traces back, in a line that never once broke, to something alive in the dark when the world had sealed itself shut. The ice is long gone. It left behind everything it made. Let that settle now. Like sediment drifting slowly down through cold water. Like the first thin crack of warmth moving across a frozen equator. So gradual that nothing alive could sense it. Only the planet itself, shifting degree by degree, remembering what it felt like to be open. You do not need to hold any of this tonight. The story has already been written into the oxygen and the cells that are carrying you toward sleep. The longest cold has passed. What survived it is here. What it became, after 25 million years of waiting in the dark, is still becoming. And tonight, in the warmth the ice left behind, the becoming continues. Quietly, patiently, the way it always has.